So, tomorrow's test is non-calculator. This question needs a calculator. So, get some kind of device. You can use Desmos or your calculator. But I want you to practice whatever device you like on how to solve this. And I took away the restrictions on solving this just for a minute. Jeremy, don't know how to start?
Yeah.
Were you here when we did inverse functions, inverse trade?
Yes.
So at the end of that, we talked about inverse function derivatives just in general.
I have I remember the 1 over thing.
Okay?
But I don't know how to apply it to this one.
Okay. So first thing, I would, okay, H is the inverse of F. Do I know anything about the coordinates?
Know that where derivative of h of -1 is 1 over f f of -1.
It's not -1.
No.
Not necessarily. So here's the point of my question. What do we know about the coordinates? Well, h of -1, what do I know about the function? What do I know about the function?
It would be equal to whatever that y value. Yeah.
So this function's y value is this function's x value, and vice versa. So I don't know what the other blanks are yet, but it's going to tell me what I need to set up, and this is why you need a calculator. What am I what am I setting up? Where does the function, not where it equals 0, but where does it equal -1? So I want to know how you guys are doing this. Like, do you know how to use the tools? So here's typing it in on Desmos, and notice this equation that I have written in pink, 2x cubed minus 3x, where does that equal -1? I could have put this function 2x cubed minus 3x and the other function -1 and found where they intersected. Instead, I'm making a single equation. I'm going to add 1 to the other side, and I'm going to look at this to see where this merged thing equals 0. Here's how we find zeros on Desmos. It's right there, and right there. put your finger on it and it shows you. Plain and simple. On a calculator, which I cannot touch anymore, on a calculator, you need to type it in, and my window's kind of tiny. So I'm going to zoom the window in, which on Desmos I could have just put 2 fingers on and gone swoop. Oh, I flattened it out. So here's my graph. So I don't want to find all 3 on the graph using the calculator because it's a pain. Evelyn, I'll let you pick. Do I want to find the one on the left, in the middle, or on the right? Middle. Okay. So to find the one on the middle, I'm going to hit second trace, which is calculate. I want to calculate the zeros on this. And then it says, what's the left bound? Is it blinking to the left of the middle 0? No?
Yes.
It looks like here's my middle 0. It's blinking to the left of it, so I'm going to hit enter. And now it says, you put a little wedge mark there, and it says, what's the right hand bound? So I have to move to the right. If I go too far, I've got 2 zeros in there, and I'm not sure which one the calculator is going to tell me. So I'm going to back up till right down there, and I'm going to hit enter. And that's got 2 little wedge bars, and it's like, hey, is this the region you want me to check? Yes. And so I say, give me an answer. And for the love of God, it finally gives me the one that I was able to just put my finger on in Desmos. When you get to, okay, the AP exam changed a lot last year. All of it is presented to you on the computer. So all calculator and non-calculator portions are on the computer, all multiple choice computer. When you get to a calculator section, Desmos is open and available to you. You are still allowed to have a handheld, which I like the handheld for some things, but for finding the intercepts and stuff, Desmos hands down the way to go. So just, if you don't have your Chromebook open, you guys okay with typing it in and put your finger on the dot? Okay. So that's the way to do it there. If you're gonna do the handheld way, it's a lot of button pushing. Okay. So we're gonna pick the one that's nice. What was the one on the far right? Was +1, right? And then Jeremy said something about this. The derivative of f at 1. What is the derivative of f? Andy, what's the derivative of f?
6x squared minus 3.
And Alex, where did I want to evaluate the derivative for f? -1 or +1?
Positive.
+1. So then, Jeremy, what is my slope of my inverse at -1?
1 over 3.
1 over 3. Okay. So we didn't do a lot on inverses that were not inverse trig. Sam?
Wait, so I see how when you plug in F1 you get -1 just by doing that, but it wasn't the 0, it says 1 0, so like what was
Okay.
Oh wait.
What I, okay, so where is it? So let's see. I could have said, where does the function 2x to the third minus 3x, where does that equal +1? So I could have done that and said, where do these two curves, even though one of them is a straight line, where do they intersect? So I get my values this way, and they've turned around. It's supposed to be a -1. Okay, so where does the stuff on the left equal the stuff on the right? I should get the same numbers that I had a second ago. I'd rather not do two equations. So where do these two equal? Well, I'm gonna just add the one to the other side and say, where does that combined thing hit 0? And that's especially useful if you're on the handheld calculator, because you guys move your stuff around, but almost always the x-axis is in the middle. And you don't want something zoomed off the screen. Yeah.
Can you do it like this?
Interesting. Okay. So he typed in f of x and then had Desmos do f inverse. Clever. That you cannot do on a handheld, so if you know what you're doing, sure.
Okay.
Okay. But I wanted to show some inverse stuff and how to use the calculator, even though tomorrow's not a calculator piece. Did you guys have particular questions you wanted to go over, or should I just kind of throw things at you? Well, at least like throw stuff at us. There were, okay, well. Let me. Everyone's favorite, implicit, woo! then you can take over.
Yeah, restart. I don't really know what you did.
Okay, I have an issue with at least one step in there. Does everyone agree with what's there? Yeah?
I don't think it's 4x y dy dx.
Yeah.
Yeah, the board's a little possessed. Put the D back next to the dy. Okay, so product rule. And you gotta decide how you wanna deal with that 4. I see the first term as 4x. So he did the derivative of 4x, which is 4, times y, plus 4x times the derivative of y, which is dy dx. So got those first two things from the product rule. The next one, power rule, multiply by the power, lower the power, and then implicit or chain rule, derivative of y with respect to x is dy dx. And then the derivative of 2x squared is 4x, leave y alone, and then leave 2x squared alone, derivative of y. Okay, now what?
Now I need to isolate dy dx.
Correct.
So I'm gonna add it this actually. Yeah, I'll do 4y minus 4xy equals dy over dx. I think that's correct.
Done in a strange way, but okay. I agree.
I can divide both sides by that, so that would be, well, I get factor out of 4 here, so be.
Change it back down to 4y.
Oh wait, I didn't see that, yeah.
Hang on, let's see.
It's always easier.
And I don't know that it's gonna help us to factor that out, but it's, you know,
Because I try to save time.
It works.
And then I get confused after class.
equals dy dx. Milo, what do we do with it from here? Are we done the question? Thanks, Constance.
No, you plug it in.
What's it?
Plug X and Y in.
Okay, what do we get when we plug x and y in?
I haven't done it yet.
You get a V?
Plug it in.
Wait,
Yeah,
Okay.
because you haven't done anything else
It's
out
actually
there.
negative, yeah, you can do it.
And in the land of labeling work, this is how you show I am plugging these numbers in to these letters. So, 4y,
And -8,
you got -8
or 8, actually.
or 8, actually. Okay, well, 4y is -24, 1 minus 3 is -2. 2 times y is -12,
Alright, so I just forgot this.
and -4 times x is another -12, plus 2x squared, which is 18. -24 plus 18,
Oh wait, it is
-6, negative over negative, it becomes positive.
Oh, yeah.
Wait,
Positive 8.
Oh,
wait,
yeah.
but the negative
No, it's
24
negative.
times negative 2 is positive 48, so it's positive 12.
Positive on the top and negative on the bottom.
Yeah. So,
-8?
yeah.
So what'd you do? So you get rid of the-
Yeah, I just divided out the line. The lines on the same side.
Just laugh.
Two lines going
Oh.
Yeah.
Entire starting equation. Yeah.
Okay.
That's what they did.
Okay. Does it not like limit the solution?
Question?
I
Sure.
kinda just like, I kinda just divide by y to make it easier. I mean, I got the same answer.
Okay, so, how did you just divide by y? Was there a y in
Yeah,
everything?
there's a y and everything, so you just
Oh.
divide by y.
In the start, you divided by y.
Yeah.
Why 0?
Well,
Yeah, so clever, and that may not always work.
alright.
Because so for here, it's not when y is 0, the coordinate chosen isn't gonna be that problem. However, if they ask for, give me dy dx, period, it needs to be there. Because the way I've been writing the test lately has been, first step, give me h prime of x,
Yeah.
so that I can give partial credit for you getting there. And then now tell me what h prime of 2 is. So I would, clever, and the way I write things, that's not gonna be valid. But, I mean, yeah, it simplifies it a lot to take a y out of everybody. Totally.
Yeah.
Lots less product rule, lots less chain rule, yeah. And, I wanted to make sure you guys saw that there are sample tests out there. Again, it used to be a 2-day test, one with calculator and one without. So the without calculator from this year, which, I don't know, 2015, might be 10 years ago. This is product rule, chain rule, trig. This one's product rule and plug in. Power rule, chain rule, trig, double derivative, so it gets messy. Yeah, ugh. What's the acceleration given the velocity? Parametrics with E and trig. Here's a basic just inverses of functions. There's really not a lot of choices, like what could the possible answer be? Arc trig with some chain rule that happens to have E, because that's fun. Natural log. The implicit where you plug in, so Paolo, this one, you'd have gotten away with it, but nothing divides out. So, and then for grins, here, there's a graph. Which one of the multiple choices could be its derivative? Alex thinks he's got an answer. What do you think?
A.
Why is it A?
Because it's when the F is like horizontal tangent, A is 0, and it's increasing towards that? Or it's positive when it's increasing and negative? when
Okay,
it's
first
decreasing?
period saw lots of different things first. They also got A really quick, but they did it differently. What he said is how I think of it as well. The original function has a horizontal tangent at, I don't know, I'm gonna call it 1. So immediately, I can throw out options C, D, and E. Those are not possible, because they're as a derivative, I need the function to hit. Let me see, 3. It has to hit 0 where that had a horizontal. These guys don't, so right off the bat, quickly you have a 50-50 guess. And then Alex said, well, the function is increasing, it has a positive slope from here to there, so the derivative had to be above the x-axis and be positive there. Yeah. Some people have been like, hey, we never covered this specific example. No, I don't have to present every possible, like, I can't do that. I'm trying to show you as many tricks that AP might throw at you, but like someone was upset that I asked for the vertical tangents, which, when do vertical lines happen? When the slope is undefined. When is slope undefined? Denominator is 0. They're like, when did we ever do that? I'm like, geometry and algebra 2 and pre-cal, and it was in the homework this year. So if you guys aren't asking those questions about it in the homework and you don't understand it, you need to ask, or maybe you need to do the homework so you know what to ask. Okay, this one is with calculator, which clearly you're not going to do tomorrow, but this was checking, can you do the derivatives and find where they're equal? Now with Desmos, this question is completely trivial because you can tell Desmos, do the derivative for me, I just don't feel like it. So I don't know how to write a calculator test very well that makes you do more thinking, that you actually need a calculator for anyway. So from 0 to pi, finding that, finding the velocity when the acceleration is 0. So do the derivative twice, check things on the calculator, and again, Desmos makes this super fast now. Okay, check the parametric equation question.
Because we can't find sets of values without a calculator.
So you might need a calculator because cosine of
Yeah.
is going to be a decimal.
Can't really, yeah, without a calculator.
But so what's the start? I want an equation of a tangent line, so I want an x and a y value. How do I find the x is 12, negative 12? How do I find the y value?
Well, you set negative 12 equal to the x in the x equation, you find t, and then you plug the t into the y equation.
Okay, first step is I need to find t. Okay, t is -2. Okay, so the coordinate, now I need a slope. How do I get the slope?
dy over dx.
dy dt is negative sine t. dx dt is 6t squared. So when t is -2, I get negative sine -2 over 24.
Yep.
Negative sine of -2 is actually sine of +2, but we won't do that. So the tangent line, y minus the y value equals slope x minus the x value. I was also a physics major for the first few years of college, and my calculator didn't work right. I left answers like that all over the place. They were like, "That's fine." It was more of a burden to use the calculator. But like the year that I gave this test, people did not know how to find t. They were like, I don't know. Okay. It was one that I hadn't covered in class, but you saw right through it. You're like, well, you need t. Set the x equal. Yeah. Other questions that were on here. Fancy irritating alphabet soup. Can you do quotient rule and read numbers out of a table? There are those. And that was the end of the calculator test. The calculator portion was usually a little bit shorter because typing everything on a regular calculator was a pain in the butt. But again, now with Desmos, these first two questions are trivial. Did you guys have questions from Delta Math? Those of you who tried them? There's some spicy things in the Delta Math. I am not recommending that you do all of it. It's over an hour if you did all of the problems. But if there's something that you feel uncertain about, it's the way to go. All right. Did we finish this one yesterday? No? That one's just mean, but sure. Go AP. anyone do step 1? It's kind of messy, but Alana, you wanna? Yeah. Your handwriting's better than mine. Yay, go Alana, woo!
Like the whole thing or just the first?
Just step 1.
Okay.
Whoops. Sorry. Okay. So, one thing's missing, which, to be fair, I did it wrong too. One thing's missing. First times the derivative of the second plus second times the derivative of the first. So here, the derivative of y was dy dx. Here, I need a chain rule there also. And it's really hard to see in the way they made this question. Andy, where are we evaluating this?
On 1, 3.
Do I need both values?
Yeah.
Yeah. Because I need f of 1, but I need g of 3. So I needed the x and the y. And it's multiple choice. I would not solve for dy dx and then plug in. You guys are much better with numbers, so make numbers happen. So I get 4 dy dx minus 14 equals 1 plus dy dx. Subtract this to this side, I get 3 of these. Add this to the other side equals. So I get dy dx is 5. And if we forget this bit right here, we get negative 11, which is the red herring, and they have that first to make you pick it. Because they're mean.